Still under rationalization of Surds. So there is something I also want to show us here. For instance, now if I have express 1 over root 5 plus root 3 in the form p root 5 plus q root 3 and find p and q. So for us to solve this now, I want us to look very well here and see how I'll be able to do. We are going to apply the way we have been using in rationalizing sort in order for us to get this value of p and q here. So we have a solution. So if, for instance, I have what they gave us is this. Remember, this is what they say we should express it in this form, and it's only when you have expressed it in this form that you can be able to get the value of your p and the value of your q. So now we have 1 over root 5 plus root 3. So according to what I told you about rationalization, also just multiply by the conjugate, which is root 5 minus root 3 all over root 5 minus root 3. So now this thing will now give us equal to, this thing to give us equal to 1 will multiply everything here. It will now be the same. 1 times this here, 1 times this thing here will give us the same thing, which is root 5 minus root 3. So, and I taught you whenever you are whenever you are multiplying the denominator of a sort that you are rationalizing, this one now here, and this one here, we have something of this nature. I'm just writing it down so that you can case plus root 5 root 3 all in bracket. Then the next one is in root 5, then minus root 3 also all in brackets. So according to what I told you previously, so we are going to have the first one, which is root 5, which is this one, we are repeating it, minus root 3 all over. Remember that I told you whenever you are multiplying sorts that are conjugate, because these things are conjugate, the denominator is two of them are conjugate sorts. So we are going to focus on this part here and this last part here. Still remember, so now this one will give me 5, while this one will give me 3. If you have not watched the previous video, you try as much as you can to do that so that you understand how this one will be only 5, while here will be 3. Why is it as if I didn't further myself in doing this thing, in trying to expand it, but I have to go straight to the point. So now this will give me root 5 minus root 3. So 5 minus 3 is 2. So now we have gotten this is our final answer. But remember, they say we should express it in this form. So we're comparing it, express it in this form. That is, express it in this form. P root 5 plus Q root 3. Still remember. So now we are going to, this is the answer we got. So we are going to express everything here now. So part of so that I know how we can express it in this one. It's only when I have expressed it in this one that I can get your P and Q. Then we'll compare them. So we now have our answer is root 5. Root 5 minus root 3 all over 2. So remember that we have this now, because this is the denominator, we can now split it into different separate fractions. So we now have root 5 all over 2, because 2 is here, like this 2. Minus is in between, minus root 3 also all over 2. If you find the LCM now, you still get back to this thing here. So now we have expressed it. Now when you look at it now, you see it as if it's resembling this thing we say which represents in the form of. So it's somehow similar to it. So now we still go further so that we can be able to get the answer. This one here is the same thing as 1/2 times root 5. This one here. And this thing is something as minus 1/2 times root 3. Are you following me now? So now the next thing now for you to be able to compare it, because what is in the at the center of these two expressions is addition, which is plus, but what is here is minus. But there is law in mathematics, you know, is that plus minus is still that same minus. So what we are going to do is to introduce plus here, which will not affect it, because plus minus will still give us plus. So now we have half times root 2 is something as half times root 5. I say root 2. It will be half root 5. We add that plus in between, plus, so that we can be able to compare it. Remember that this one has minus 1/2 root 3. Now it's similar. Looking at this now, here now, this one I'm circling is similar to here. Why here is similar to here. So therefore my p, if it's similar, this is root 5. What is at the back of root 5 is p. This is root 5. What is at the back of root 5 is 1/2. So p is now 1/2. And q is 1/2. Q is equal to, what is at the back of root 3 here is q. What is at the back of root 3 here is minus 1/2. Minus 1/2. So you have gotten your p and q to be 1/2 and minus 1/2. Another. So that is how to also apply Surds rationalization in getting some values or known values depending on how they say you should express it to be. Another. So this is one example I also want to show us under that same rationalization of Surds based on where we stopped yesterday. So that is what I'm trying to show. We have gotten p, we have, because they can also give it here and say express this thing in this form and all that. This thing, if you know it very well, if you know this thing very well, it will not take much time. A minute is enough for you to get the answer. Yes, a minute is enough for you to get the answer if you know it very well and all that. So that is it. Let me just review it once again so that you get to understand. In case you didn't get any part. So you see the question, see the solution where I started from here and all that. So now got the answer to be p equals to 1/2 and q equals to minus 1/2. As simple as that. So that is how to express this.